We are going to continue learning about trigonometry. So this lesson, we're going to introduce the law of sines. So in order to use the law of sines, you still have to know your trig ratios. You still have to know your special angles, your reference angles, the signs of the trig ratios in the 4 different quadrants, and converting between degrees and radians. So this is the law of sines, which says that sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. And remember, these sides are going to be across from their corresponding angles. So side A is across from angle A, and side B is across from angle B, and side C is across from angle C. And just because this ratio is in the middle, everything is equal to each other. So you could actually use sine A over A is equal to sine C over C. You can do those as well. The important thing to remember is that you have to have one complete ratio before you can use the law of sines. So here we have this angle, and the corresponding side to this angle would be the 5. And then we have this angle, 50, and the corresponding side would be the 4.1 because it's across from it. And then we have this angle, 60, which we could have solved by doing 180 minus 70 minus 50, which gives us 60. And then we can actually solve for this unknown side using law of sines. So we can use sine 70 over 5 is equal to sine 50 over 4.1 equals sine 60 over our unknown side. So if we wanted to, we can cross multiply here and then solve for our unknown. So you can use the law of sines if you know any 2 angles on a side. So angle, side, angle, or angle, angle, side, if you remember from geometry. You can also use this law if you know 2 sides and 1 angle that is opposite one of the sides. So that would be an SSA triangle. So let's look at this triangle. Can we use the law of sines for this triangle? The answer would be yes, because we have a angle, angle, side. Okay, we can also use law of sines for this one because we have angle, side, angle. And we cannot use law of sines on this one because we have side, angle, side, which is not one of the triangles that works for law of sines. So we would have to have side, side, angle. Like this one. So this one we have side, side, angle, which means that this one we can use the law of sines on. Okay, so you try this one. Can we use the law of sines on this? Okay, you should have said yes, because we have angle, side, angle. Can we use the law of sines on this? Okay, you should have said no, because we have side, angle, side. Okay, so when we use the law of sines, don't forget that if you're trying to find a missing angle, and we're already given 2 different angles, to find the third angle, all we have to do is subtract from 180, because all angles add up to 180. So in this case, angle B would be 140, because 180 minus 15 minus 25 is 140. Let's say we want to find side C. So we can use law of sines here. So the known ratio that we have is the 140 to 6. So we can use sine of 140 over 6. And if we're trying to solve for side C, we're going to use sine 15 because that's the corresponding angle over C. Then we'll cross multiply, which means that c times sine 140 is equal to 6 times sine 15. And then we'll divide both sides by sine 140. So that means c would be equal to 6 times sine 15 divided by sine 40. And as long as you're in degree mode, you should get the answer 2.42 after you round to the nearest hundredth, like the instructions say. Okay, so now we'll try another one where we try to find side A. So again, our known ratio is going to be the sine 140 over 6. And since we're trying to find side A, we're going to use sine 25 over A. Okay, and then we'll cross multiply. So that means that A would be equal to 6 times sine 25 divided by sine 140. And then as long as we're in degree mode, we should get 3.94 if we round to the nearest hundredth. So to find angle B for this one, we can do 100 minus 39 minus 62. We get 79. And to find side C, we're going to use our known ratio of 39 over 4. And then we can use, since we're trying to find side C, we'll use sine 62 over C. So when we solve, we're going to have to cross multiply. So we'll get C times sine 39 is equal to 4 times sine 62, which means that C is equal to 4 times sine 62 divided by sine 39. And that's how we get our answer of 5.6 if we round to the nearest tenth. Okay, so for measure of angle A here, we would do 180 minus 12 minus 92, and we would get 76. Now to find side C, we have to have a known ratio. And so remember that we have this 92 over here. So sine of 92 over 4 is our known ratio. And to solve for side C, we're going to use sine 12 over C. Then we cross multiply. So we'll get 4 sine 12 is equal to sine 92, which means that C is equal to 4 sine 12 divided by sine 92, which, if we're using degree mode in our calculator, gives us 0.8 after rounding to the nearest tenth. Okay, to solve for side A, we're going to use our known ratio, which is the sine 92 over 4. But we have to know what angle A is. But we solved for angle A earlier, and we know that angle A is equal to 76. So sine 76 over side A, which is what we're trying to solve for. So we cross multiply. So A times sine 92 is equal to 4 times sine 76. So to solve for A, we get 4 times sine 76 divided by sine of 92. And as long as we are in degrees in our calculator, we should get 3.9 after rounding to the nearest tenth. So again, this is our law of sines. And remember, you have to have at least one known ratio and then one part of the unknown ratio. So remember in geometry, when we learned about the different triangles, the side-side angle did not prove congruence. And so side-side angle was one of those triangles where you could not use it unless you were using a right triangle. And what happens is that you can't make a triangle with the measurements that you get when you solve for it. And so, we call it an ambiguous case when you have a side-side angle triangle. You can either have 0 solutions, 1 solutions, or 2 solutions, depending on when you check your work to see if the measurements work out. If you get an answer when you solve for an angle, there is going to be either 1 or 2 triangles. So to figure out if there's going to be 1 or 2 triangles, this is what you can do. If the triangle is possible, find the second quadrant reference angle, and then after that, the sum of the 2 known angles is less than 180, then you're going to have 2 different triangles.